Hello all, welcome back. So in this lecture we are going to learn about column oriented storage and row oriented storage. So let me first start with row oriented storage. Okay. So many popular DBs like MongoDB, Postgres, MySQL, they use row oriented storage. So what it basically means that a whole row is stored at a disk, I stored in the same place. Okay. So, like we know how the disk works actually. So disk actually looks like this, okay. And at a time we can read only this much. So let's say this is 512 bits, okay. So let's say our DB looks something like this, okay. So these are all the employees, let's say in a company, okay. So first we have like row ID, employee ID, full name, last name, sorry, first name, last name, and salary. Okay. And ID is like 16 bits, employee ID is 16 bits, first name is 64, last name is 64, and salary is 16. Okay. So each row is of 176 bits. Okay. So if we see like in one block, how much data can we store? So in one block, we can store like uh, so 176, right? So if we do 176 into 2, we get 352 bytes. So 352. Okay, and if we do it like 176 into 3, we get approximately 528. Okay, so 528. So like in each block, if we can store 512, okay. So only two row can be stored in each blocks. Okay, so two row can be stored in each block. So again, so like this is one, this is two, and this will be, if there was another, this will be three. Correct. So let's say so yeah, in row oriented storage, this whole thing will be stored at single place. Okay. So this is row oriented storage. Now, let's say I want to query, I want to make a query where I want to search like, uh, give me all the, I mean, give me the average salary of the whole company. Okay. So in that case, we have to jump three blocks, right? We have to read three blocks, and we know like reading three separate blocks can be extremely slow in a hard disk, right? uh, let's say like each block reads like in 1 second. So like reading three blocks will take total of like 3 seconds, which is like slow. So what we can do now, here we come to the concept of uh, column oriented storage. So if we store all the columns at a single place, okay, in that case, what will happen? So like there are five employees, right? And if we store all the five employees data at one block, then we like this is 16 bit, right? So it will take like 16 into 5, which is 80. 80. So we can actually store much more salaries in one block actually, right? So in this case, salary, if we want to like find the average salary of the company, in this case, column oriented storage is more suitable. Okay. So in generally, how does DB actually stores column? So mostly what it does that it stores the data of the column. So for example, it will store something like 1000, which is in ID 001. Again, it will store like 2000, which is in ID 002. Again, it will store 2700, which is in ID 003. Let me just write it down. So basically, in the column oriented storage, all this data will be stored in this form. Okay, will be stored in this form. So like 001, the employee ID is 123. For 002, the employee ID is 234. Similarly, so like this was for employee ID, this was for first name, this was for like salaries. So 001 we have the salary 1000, 002 we have 2000, 003 we have 2700, and on more. Okay. So why do we store this index also? So the reason why we store this index, because mostly in column oriented storage, uh, if we want to do a range query, in that case, uh, the values will be sorted in form of so in this case, like the values will be sorted as per salaries, right? But if it is sorted, how will we know like for which employee the data was? So let's say if it was sorted and like af after 150 1000 will come, right? Then how will we know that 150 was for which employee? So it is for Donald Trump. So for that we store the index value also. Okay, cool. So now we know like range query or finding the average, all those kind of things are better if we have column oriented storage. Cool. What is the second benefit? Second benefit is basically we can also do lots of column compressions. So uh, there are there are many algorithms, okay, which we can use for compressing the column. So for example, if all this was 80 bits, okay, and even if we store the IDs, it will be 80 plus 80, which is 160. By column compression we can actually make this even like less than 160, so you can store much more data in one block, so the reading will be fast. Okay, so now like pros and cons of row oriented storage versus column oriented storage. So basically, these are the use cases, like these are the times when column oriented storage are better. So basically, if you want to do analytics, okay, if you are having a large data set, okay, if you are if you want like very less query latency, okay, that time also column oriented storage is very good. Okay. Uh, Column oriented storage are like mostly less strict when it comes to ACID compliances. Why? Because like for example, when we are sorting this thing, okay, now let's say we are updating something, then it have to like do many transactions, right? It have to first see like in index one, let's say you increased Donald Trump's salary by like $150 to like $1,500 because you made some mistakes. Then at that case you have to see like for which index it was, then you have again have to sort it, blah blah blah, lots of operations, right? So mostly it is uh, less ACID compliant. Okay. uh, Fourth, you want to do column oriented storage when you only add new data, okay, only when you append new data. Okay. And last but not least, like when your application is like read heavy, and read heavy plus analytics kind of thing, okay, so at that time the column oriented storage is better than row oriented storage. Now when is row oriented storage better than column oriented storage? So row oriented storage are more beneficial when you have like transactions, okay, low query latency, okay, your DB information is small, okay, like you have less data set, you need very strict ACID compliance, okay, also the frequency of update is like very high, okay. So for example, if you are using Facebook, okay, and you want to load your page or anyone's profile, you have seen a hot chick in a bar and you want to load her profile, sorry. Okay, so if you open, you want all the data related to her profile, right? You want to see all the data related to her profile. In those cases, like row oriented storage is better. In that case, if you have column oriented storage, you have to jump around the blocks because there is only one column's data at a time, right? So in those kind of scenarios, row oriented storage are better. So now some examples of row oriented storage versus column oriented storage. So these are some of the examples who use column-oriented storage. For example, Amazon Redshift, Google BigQuery, Snowflake. Okay, and some of the example of row is, so examples are like PostSQL, MySQL, MongoDB is actually document-oriented database. It's not exactly row-oriented database, but the like theory behind is almost same. Okay. So yeah, these are the examples. So from example, what we can see mostly like analytical, all those kind of databases are using column-oriented storage, and like where you need the whole row, or like there are queries which are like interrelated where you need the whole rows data. On those kind of cases, row oriented examples are like mostly used. Row oriented storage are mostly used. Okay, thank you.